Alright, here we are on the bottom of page 1 of the notes for section 1.1. And I'm sorry for the delay here before getting started. I just want to double check that we're in focus. This is my second take on this video because the first one, the autofocus, went wacky on me, so bear with me here. Okay. So now that we've established some of the definitions for our vocabulary, let's use some of it and let's see what we're doing here with our beginning algebra working with variables. And the instructions say to evaluate each expression for x equals 7 and y equals 5. So some keywords pop out here. Evaluate, an expression. We've seen and heard these before. Evaluate, we talked about, that means we're going to be substituting. So we're going to substitute a value in and we're going to find the result. That's what evaluate means. Okay? And then the fact that it's an expression means there's not going to be an equal sign. We're not trying to solve an equation. We're just going to replace or substitute the x and y with some given values. And in this case, we've been given 7 for x and 5 for y. And again, pardon the interruption, I'm just going to double check that we are staying in focus. Okay, that seems to be working pretty good. I will trust that the rest goes smoothly. Here we go. Pardon me, I've got something caught in my throat as well. Things are falling apart all over the place. So as you start to do problems, one thing I would recommend is that you go ahead and copy the original problem straight from the book onto your paper before you start doing it. A lot of errors happen when you are starting the problem simply because you see the problem in the book, you go to your paper and start doing one of the steps right on your paper. And what that happens is there might be a little bit of an error, you might misread, you might drop something, and you end up doing all this beautiful work and your algebra and your math is just fine, but you're starting off because essentially you have a copying issue. There was a dropped number or a change sign or something like that. And you'll notice one of the techniques I use is once I've copied it and then I take my first step, especially when I'm having to plug things in, I go ahead and leave myself some workspace. So I'm going to rewrite this problem 3 times x plus y, but instead of x and y, I leave some blank spots. Because in this case, we're going to replace the x with 7. So 7 goes here instead of the x. And we're going to replace the y with 5. Those are the values that were given that we're now going to evaluate. And now we're going to figure out what this result is. So in this case, order of operations will tell us what we need to do first. Do we do the 3, the 7, the 5? What comes first here? So this is a good chance to review that. Order of operations, hopefully that sounds familiar to you, or it will unrust very quickly. Some of you may have learned some sort of memory trick to keep it straight. The one I remember from my first exposure to order of operations was, please excuse my dear Aunt Sally. Please, parentheses, excuse, exponents, my, multiply, dear, divide, Aunt Sally, add and subtract. So let's write those in here. P is for parentheses. And what we're talking about is dealing with what's inside the parentheses. And in fact, what it really is meaning is all the grouping symbols. So brackets, braces, they look like these fancy French little things. They're not really French, they just seem extra fancy to me. The fraction bar, okay? In the next example we'll see a fraction bar that's used as a grouping symbol here. E is for exponents. We won't see a lot of those yet, but they will come into place and we need to know where they fall in the order of operations. After that, you deal with any multiplication and division. you multiply and divide, and you deal with these at the same time, simultaneously, together. And you don't pick one over the other, you just take them as they come, left to right. And finally, Aunt Sally, you add and subtract. Same as multiplication and division, you deal with them together at the same time, simultaneously. The way you decide how to do it is you just read the problem from left to right, and you take the addition and subtraction as they come in order. Okay, so let's go back to where we were. We were at 3 times 7 plus 5. So order of operations says to deal with what's inside the parentheses first. So 7 plus 5 is 12. So we've got 3 times 12, and that is going to be equal to 36. So the addition came first simply because it was inside that grouping symbol. It was inside the parentheses. Then we were able to look at what was left. There was only one operation, so we went ahead and did it, but it was multiplication, 3 times 12. Now let's try I want to say one more thing before we try number 24. If you had a little gut instinct to distribute that 3, that's beautiful. That is an algebraic skill that we're going to apply as we go through this term, and it's great. In fact, you could have distributed that 3 across the 7 and across the 5, and you should get the same answer. 3 times 7 is 21, plus 3 times 5 is 15, and 21 plus 15 is 36. So great gut instinct. The only reason why I'm doing it like I showed here is just to demonstrate the order of operations. What's beautiful about math is there's often more than one way to do the problem and still get to the same answer, so it's a great way to check yourself. Okay, let's look at the next one. 2y minus x plus 24, the whole thing over 2x minus y. It's essentially a big fraction. This fraction bar is going to be working as a grouping symbol here. And I just have that sneaky suspicion we might be out of focus, so I'm going to check. Oh, things are looking good. Okay, now I really will trust all the way to the end. Okay. So here we are with our problem. Again, we've copied it directly from the book onto our paper so that we don't drop anything or have any copying errors that lead us to do this entire problem wrong. And then I'm going to go ahead and rewrite the problem but leave some space for myself for the x and y. So 2 times y minus x plus 24. The whole thing over 2 times x minus y. So the parentheses I'm putting in here now are not necessarily grouping symbols, they're just holding a spot. And it also does the job of showing me that it's multiplication here, the 2 times y, and on the bottom the 2 times x. So parentheses have a lot of different things that they can do all at the same time. X equals 7, y equals 5, so it's 2 times y, y is 5. Minus x, x is going to be 7 again. These were values we were given to evaluate. Plug these in, see what happens. Over 2 minus x, which is 7. I'm sorry, not 2 minus, 2 times x minus y, which is 5. And then we'll go ahead and simplify to see what we get here. According to order of operations, we need to deal with whatever's happening on top of the fraction, separate from what's happening on the bottom. And on the top, we've got multiplication, subtraction, addition. So according to order of operations, we'll deal with the multiplication first. So 2 times 5 gives you 10. And then you're left with the minus 7 plus 24. On the bottom, we've got multiplication and subtraction. Multiplication comes first. So 2 times 7 is 14. And then you have the minus 5. And pardon me as I need to kind of change my level here because I ran into my notes, my own notes. On the top now, all we have left is addition and subtraction. So I'm just going to go left to right as I deal with that. So 10 minus 7 is going to be 3 plus 24. And then there's only one thing left on the bottom, so we'll just go ahead and do that. 14 minus 5 is 9. And then we can move ahead 3 plus 24 on the top is 27, whole thing over 9, and that reduces to just 3. So when you evaluate, you're going to end up with a result here, and for number 24, our result is 3. So take a moment to what I call TQC, tell question copy. You're going to see this throughout the notes. And it's really critical to get the stuff into your memory for long term. It's one thing to be able to follow along and watch somebody do a problem and go, yeah, I get that. I understand what they're doing there. But that's not enough to get you ready to do the problems on your own in a test type situation. You have to take it to the next level. And one way you can do that is to start internalizing and owning it for yourself. You can do that simply by tell somebody or talk out loud what you just saw happen and explain it in your own words and recreate it for yourself verbally, and you'll hear it, you'll be able to talk about it, you'll use words that make sense to you. It really will start to cement that information in your brain so that it's ready to pull back out again for exams. So that's what I mean by tell. Talk it through. If you have someone near you who can be a live audience, that's amazing. That's great. What a privilege. If it's just you, just talk it through for yourself, okay? Even that helps. As you go, if there's still things that aren't making sense to you, or you have questions, or things you think of, hey, well, what about this, or what if this? Highlight for yourself somewhere on the page. Use like a highlighter or a star or a question mark or something, so that when you do get to your help resource, whether it be a tutor or a friend, your study group, coming to class, whatever it is, where you're going to get your question answered, you can quickly skim through your notes and go, oh, there's one. That's one I wanted to have questions. And you might want to put a few words to it too. Right now, of course, it's obvious what your question is as you're looking at the page, but give it a day or even a couple hours. I don't remember what my question was, so put a couple notes down for yourself. Write it out, what the question is that you have, so that when you get to your help, you can get right to working on the question rather than spending time trying to remember what it was you were curious about. Okay, then make sure you've copied, so tell yourself or someone else what's going on, note any questions you might have, and then make sure you've copied everything you need to copy for your notes. Think of your notes as a personal tutor that you're going to take with you when you start the practice sets. So you don't just want to write what you see on the page, you want to write down what you hear me saying, and definitely what you hear your own head saying, what you think about, what's causing the light bulb to go off, what's causing things to click and fall into place for you. Write those things down. That's going to just make a world of difference when you're working on the assignment and as you're preparing for exams too. So take real detailed notes. Copious is a word I like to use for that. Copious notes. And that's going to start with more than just copying. Add some things that you hear and think as we're going along here. Okay, finally, after we do some watch problems, you'll get a chance to do a try problem. And here's your chance right now. So I will ask you to pause the video and do the tell question copy, and then come back and try this one, and then when you're ready, hit play again, and I'll reveal the answer. Okay, if you haven't tried number 22 here at the bottom of the page, now's the time to pause the video, because I'm going to reveal the answer, and it should be 8. And again, we're using the same x and y value from above, 7 for x, 5 for y. The other thing I wanted to mention is that I deliberately pick the examples to do on the notes and then of course to do in class, and the try question is where we'll start in class. I'll go through all the tries, so if there's any issues, you don't get the same answer, we'll deal with that in class. But the way I pick them is I pick kind of a introductory type problem, fairly straightforward. I jump to a fairly challenging one out of that particular section that we're in, and then for the try problem I kind of go middle of the road, somewhere in between the easier and the challenge. Now that's not always the case. Sometimes I mix it up a little bit more and make the try one a little bit more of a challenge, But all that to say, the notes are meant to be a beginning for you, and they're meant to be a place where you can start the practice problems in the homework. And the practice problems are meant to take you through several levels, and they will get more challenging. And my advice to you is follow the steps, do what you see being done in the notes, follow what's being said, even on the easy problems that you don't even need to blink at, the ones you could do in your head or in your sleep practically. Follow the steps on the easy ones, because as they get harder, and they will get harder in every section, you'll be able to apply those steps. You'll have practiced them enough, you're ready to do the harder ones. And the harder problems will push you, they'll stretch you, but that's what this class is meant to do. It is meant to make you stronger thinkers, better learners. Even if you never use math outside of school, or outside of this class, or you don't use algebra. We all use math, right? But the whole idea of algebra, you'll use the thinking skills and the translation skills and the different things that we're going to be learning this term. You'll use those brain area skills, and the homework is a chance to really exercise those parts of your brain and make them stronger. So hopefully that's an encouragement to you. We'll see you on the next page of the notes.